Welcome back. This is an Aleks training video on calculating an equilibrium constant from a heterogeneous equilibrium composition. Heterogeneous means that you've got a mixture of different states. So if you look at the balanced equation, you've got solid calcium carbonate here, and then solid calcium oxide here, and then gaseous carbon dioxide here. If you are trying to determine the constant of whether it's going to go right or left, so you're an equilibrium constant, you really can totally ignore anything that's in solid or liquid form. The reason is because they are not able to change. The grams per mole or they can't compress at all, okay? So the amount of mass divided by the amount of space is always going to be the same in a solid and a liquid. So for that reason, it can't change. You can just express that number as it's like a constant. It doesn't do anything to the number. So when you're trying to determine whether it will go forward or backwards, you're really only considering the gas phases. That makes it really easy. You just ignore the others. Anything that's not a gas is not going to be written down when you do your expression. Okay, so if you remember an expression is going to be the concentrations of the products taken to the power of the coefficient in the balanced equation divided by the concentrations of the reactants taken to the power of its coefficient. Okay, so if I'm going to write a coefficient or an expression of this K, I'm going to have whatever the concentration is going to be or whatever the constant is going to be the concentration of carbon dioxide taken to the first power, since this is to the first power, and then it's divided by nothing. Okay, there is nothing else that I'm going to put it in. So this is solid, so I'm not going to put anything over here because it's a solid. It's not going to change at all. And this on the bottom is a solid, so I'm not going to divide it at all. So anytime you have a heterogeneous composition, you're simply going to ignore all the solids and liquids and then write your expression only using the gases. And in this case, that's all I've got. I want the concentration of carbon dioxide gas, and my constant is based upon that concentration. Okay? Well, great. If they give you the concentration, you're done. This one doesn't. This is making us work for it just a little bit. They're saying that at a certain time and a certain temperature or whatever, you've got these amounts. You've got so many grams of this and so many grams of this and so many grams of this. Well, I'm only interested in the calcium or the carbon dioxide. Ignore everything else. Who cares? Because it's just a constant. So I'm going to take this, turn it into moles. Remember, this is a molarity. Okay? I need to take the number of moles and then divide that by the amount of liters that you have. Okay, so let's do it. It says that I have 22.1 grams of carbon dioxide, and when carbon is 12 and oxygen is 15.9994, okay, when I take that by 2 and add it up, so the molar mass of that, I'm going to get that as 44.0095 grams per mole. Divide that out. I'm going to get 0.50216 ... That should be enough. Remember, you're going to do this to 2 significant digits, so as long as I've got several after, I don't have to write down everything in the calculator. So I've got 0.50216 as moles. So that's moles of carbon dioxide. And if you remember, molarity is moles of solute divided by liters of solution. Well, how many liters do I have? It says at a certain temperature, a chemist just finds that 9.6 liter reaction vessel. Okay, so I'm going to take my moles, 0.50216 moles. I'm going to put it over 9.6 liters. And my molarity now, okay, is 0.052308 dot dot dot, as long as I got a few notes here, moles per liter. Okay, that is the molarity, and that's the concentration of that. That's what this is. That's the concentration. That's what the brackets denote. They're talking about the molarity, or the concentration you have there. So, what did they ask for? Calculate the value of the equilibrium constant C for this reaction. Well, if the value of K sub C is simply the concentration of the carbon dioxide, well, the concentration is this per mole, then your answer is simply that. It's going to be K sub C equals 0.052, two significant digits. So I had to drop the 308, and that's it. That's how you do it.